Along with our multiplication properties of exponents, we also have a zero and negative exponents property. The zero property is right here. What this says is that if you take any number and raise it to the 0 power, we get 1. And just something you kind of have to memorize. This means if we have 4 to the 0 power, that equals 1. If we have 512 to the 0 power, that equals 1. If we have a negative 8 to the 0 power, it equals 1. Anything raised to the 0 power is 1, as long as it's not 0. We can't raise 0 to a 0 power. The other property is when we're dealing with negative exponents. What this one says is if we take any number and raise it to a negative integer, it becomes its reciprocal. So a over negative n becomes 1 over a to the positive n. So not only are we taking the reciprocal of it, but we're losing the negative. So for example, if we had 5 to the negative third, that becomes, think of it almost as a reciprocal, 1 over 5 to the third. If we had 2/3 raised to the negative 7, we can write that as, again, reciprocal, 3 over 2 to the positive 7th. And again, we could continue on with that, but just to show you an example that we're thinking of it in terms of reciprocals. So let's look at a bunch of different examples. The first one right here is 3 to the negative 4. Again, think of it in terms of reciprocal, but it's a reciprocal without the negative. So if I think of this over 1, my reciprocal would be 1 over 3 to the positive 4th. Now we could write that out as 1 over 81. Again, the kind of rule to follow is if it seems like a reasonable number, 3 to the 4th equals 81, that's pretty reasonable. You can actually work this out. If it's a pretty big number, you can leave it as an exponent. Looking here at part B, we have negative 5.2 raised to the 0 power. Remember, anything raised to the 0 power equals 1. C, 4 to the negative y. Again, think of it as a reciprocal without the negative. So this becomes 1 over 4 to the y. That's it. We really can't do anything else with that one. Right here, 3/5 to the negative 1. Again, reciprocal. That becomes 5/3 to the positive 1. Well, that positive 1 doesn't mean anything, so this is just 5/3. The last example on this slide, 0 to the negative 1 power. Well, if we think of it in terms of reciprocal, we end up with 1 over 0 to the first. And hopefully that looks a little strange because we really cannot have 0 on the bottom of a fraction, because that means divide, and we can't divide 0. So what we say for this one is it's undefined. Okay, so just be aware that if you have 0 on the bottom, it's undefined. It's not possible. We can't divide by 0. Let's look at some more examples. The directions here say rewrite with positive exponents. Assume k is positive. So we're just assuming that when this is a negative k, it's a negative number. With these, as you get ones that are a little bit more involved, it's important to remember that we're talking about multiplication here. This is what I mean. This means 4 times 3 to the negative k. So work each part individually. 4 times, remember if we take the reciprocal of this, we get 1 over 3 to the k. Now if we multiply these, this ends up being 4 over 3 to the k. Don't change it to a mixed number or anything, just leave it as 4 over 3 to the k. Okay, and that is as simplified as we can make it. Look at this next example. This part here always messes people up because they want to say that this negative 3 goes with a 5. It doesn't. This is 5 times g to the negative third times h to the negative fourth. And I really encourage you to write it out like this. We can't do anything with our 5, but we can take the reciprocal and go 1 over g to the third, and take the reciprocal and write 1 over h to the fourth. When you do that, now you can just multiply across the top. 5 times 1 is 5. And 1 times g to the third times h to the fourth. G to the third, h to the fourth. Okay, again, the more you work with this, the easier it will become. Let's look at some more examples. The directions here say evaluate the expression. We have 4 to the third times 4 to the negative third times 4 to the third. When you kind of get even more involved, you're going to realize there's more than one way to do this. One way we can do it, working on our 0 and our negative exponent properties, is to rewrite this one as 1 over 4 to the third. Times that by just 4 to the third over 1, and we end up with 4 to the third over 4 to the third, which divide out to give us a 1. Now let me show you another way to do this. If you look right here, if you remember, if it's the same base being multiplied, we can add the exponents. We can go 4 to the negative third plus 3, which would be 4 to the 0, and remember, anything to the 0 power equals 1. So there's two different ways of doing it, but you get your answer of 1 either way. Look at this one here. Again, a couple different ways to do this. We could just literally use the idea of we have our power here, 5 to the negative 2, being raised to another power, which means we can multiply them. Negative 2 times negative 3 ends up being 5 to the positive 6. And if you were to write this out, that would be 15,625. That one's kind of an iffy one. I'd probably accept either. Another way we can do this is to think of this part right here in terms of its reciprocal. We could rewrite this as 1 over 5 to the second, and then raise that to the negative third. And again, if we're raising it to a negative, we think of its reciprocal. This becomes 5 to the second over 1. Now all that's raised to the third, and you still get 5 to the sixth. Okay, so either way it makes sense to you, you get the same answer. So that's going to equal your 15,625. Even this 2 here, 2 to the negative third. Remember, take the reciprocal, so 1 over 2 to the third. So we take the reciprocal and that gets rid of the negative. And 2 times 2 times 2 is 8, so we can just write that as 1 over 8. So again, you can use all of your different properties to get your solutions. And there's more than one way to get there. One more page. Rewrite the positive exponents. Again, assume n is positive. Okay, so that'll play into effect here. So I want to rewrite with positive exponents, and I have a negative 3 here. So use your properties. This is like saying 4 to the negative third and y to the negative third. So that's like saying 1 over 4 to the third times 1 over y to the third. And that's 1 over 4 times 4 times 4 is 64. So I'm going to write this as 64y to the third. Another way to think of it is to think of this over 1 and just say that this is 1 over 4y to the positive third. And you're going to get the same answer. 1 over 4 to the third times y to the third. So 1 over 64y to the third. Again, two different ways of looking at it. Let's look at this next one. If you look here, you could think of this as 1 over, and kind of treat this bottom one here as a reciprocal. 1 over g to the 2n. Well, dividing by a fraction is the same thing as multiplying by the reciprocal. So instead of dividing by 1 over g to the 2n, we could multiply by g to the 2n over 1. And all these ones here basically just works out to g to the 2n. Another way to kind of look at this, because there is a 1 already on top, it's kind of like working backwards. I could rewrite this as g to the negative 2n raised to the negative 1 from here to here. Because again, if I was given this problem originally, I would take the reciprocal of it. Now we have a base, or I should say a power raised to another power. That means I can multiply negative 2n times a negative 1. When you multiply that together, you get g to the positive 2n. Okay. So again, just try some of the rules when you're working on these. You're probably not going to be wrong as long as you're using the rules correctly, because there's more than one way to get to the answer. And again, the more you practice this stuff, the easier it'll become.